We're going to have a look at solving two different types of logarithmic equations. Starting with part I, what we notice is that what we want to solve, the variable x, is a power. In order to bring it down from a power to a coefficient, we need to apply logs to both sides, because there's a log rule where you can bring the power down as a coefficient. Now it makes sense to choose the base of the log that matches the number here. And I'll show you later on in this question why we chose this specific base for the logarithm. So let's now apply that log base 8 to both sides of the equation. So we have log base 8 of everything on the left hand side equals log base 8 of 24. Like I mentioned before, we can take the power down as a coefficient now. So we have 2x plus 1 all multiplied by log base 8 of 8 is equal to log base 8 of 24. Now, the reason I chose log base 8 is because log base 8 of 8 is just 1, meaning 2x plus 1 all multiplied by 1, which is just 2x plus 1, would be equal to all of this, log base 8 of 24. From here, you can just find the value of x by rearranging. So subtract 1 from both sides and divide both sides by 2 to get x equals log base 8 of 24, all take away 1, divided by 2. Now, you can put this in the calculator and it'll give you your answer to 3 decimal places. Hopefully that all made sense. And yeah, let's move into part 2 of the question, which is a bit more difficult in my opinion. Here we're going to use a rule that when you subtract logarithms and the base is the same, then you divide the insides of the logarithms. So using that idea on these first two terms, we get that the first two terms can be simplified into log base 2 of 11y minus 3 all divided by 3. So let's try that out. 11y minus 3 all divided by 3. Take away 2 log base 2y equals 1. So we're almost at a point where we can combine these two logarithms as well, but there's a 2 in front of the log, which keeps us from using that division rule. So what we do here is the opposite of what we did before. Before we took the power down as a coefficient. Here we can take the coefficient forward as a power. So we can write this out as log base 2 of y squared. Now that these are both log base 2 terms, we can divide the insides of the logarithms. So we can say log base 2 of 11y minus 3 over 3 all divided by y squared. Let's write that out here. So when you divide by y squared, that's essentially the same as multiplying by 1 over y squared. So it just becomes 11y minus 3 times 1, which is 11y minus 3 for the numerator, all divided by 3 times y squared, which is 3y squared. And all of that is equal to 1. From here, you can use what you know about rearranging logarithms. You can bring the base forward. You can bring what's on the right hand side as a power and make it equal to what's inside of the logarithm. If you're ever confused about where the positioning is, try to remember this template that if 10 squared is equal to 100, then log base 10 of 100 equals 2. This tells you that the base comes forward like it does here. What's on the right hand side becomes a power and it becomes equal to what's inside the logarithm. That's the fundamental idea that we used here. 2 to the power of 1 is just 2, so I'm just going to write this as 2. Now we just sort of rearrange, so multiply both sides by 3y squared. So you get 6y squared equals 11y minus 3. Take all the terms to one side and solve it like a quadratic. So let's do that. Taking away 11y and adding 3 to both sides, we get 6y squared minus 11y plus 3 equals 0. Multiplying your a and c term, 6 times 3 is 18. What two numbers multiply to give positive 18 and add to give minus 11? Well, it's minus 9 and minus 2. You put those in a bracket with 6y. So 6y minus 9. You might have a different method for doing this. That's completely fine. And then you simplify both brackets as much as possible. So this first bracket, and both these terms are factors of 3, so we can divide everything by 3 to make it 2y minus 3. In the second bracket, both of these are factors of 2. So you can divide both by 2, both terms by 2, that is. Now when the first bracket is equal to 0, y is equal to 3 over 2. And when the second bracket is equal to 0, y is equal to a third. And just double checking the question, it wants y to be bigger than 3 over 11. And you might have to double check, but 1/3, I'm just going to double check if 1/3 is bigger than 3 over 11. So the easiest way is to make it so that the denominators are the same, so they can easily be compared. Let's multiply top and bottom of this fraction by 11 to get 11 over 33. Multiply top and bottom of this fraction by 3 to get 9 over 33. And a third is therefore bigger than 3/11ths because 11 over 33 is bigger than 9/3. So both of these are valid solutions for your final answer of y. Quite a lot of steps involved in that question, but hopefully it all made sense. We either use the power rule of logarithm or the subtraction rule, where you divide the insides of logarithms. We also use this template in one occasion as well. If you'd like me to make more videos about logarithms, just let me know in the comments. Otherwise, be sure to like the video if it helped and subscribe. I'll post more content like this.